Hi everyone, welcome to Electronic Circuit Lab. Today our course is about Zener diode characteristics. Here is our contents. 1.1 What is a Zener diode? A Zener diode is a silicon semiconductor device that permits current to flow in either a forward or reverse direction. The diode consists of a special, heavily doped p-n junction, designed to conduct in the reverse direction when a certain specified voltage is reached. The Zener diode has a well-defined reverse breakdown voltage, at which it starts conducting current, and continues operating continuously in the reverse bias mode without getting damaged. Additionally, the voltage drop across the diode remains constant over a wide range of voltages, a feature that makes Zener diodes suitable for use in voltage regulation. Show in Fig. 1.1 is a typical Zener diode. 1.2 Zener diode operation. The Zener diode operates just like the normal diode when in the forward bias mode, and has a turn-on voltage of between 0.3 and 0.7 V. However, when connected in the reverse mode, which is usual in most of its applications, a small leakage current may flow. As the reverse voltage increases to the predetermined breakdown voltage, Vz, a current start flowing through the diode. The current increases to a maximum, which is determined by the series resistor, after which it stabilizes and remains constant over a wide range of applied voltage. Show in Fig. 1.2 is a Zener diode IV characteristics. What is Zener diode used for? Show in Fig. 1.3, Zener diode shunt regulator. Zener diodes are used for voltage regulation, as reference elements, surge suppressors, and in switching applications and clipper circuits. The load voltage equals breakdown voltage Vz of the diode. The series resistor limits the current through the diode and drops the excess voltage when the diode is conducting.
Okay, hi everyone. This is your week 14 assignment, Zener diode characteristic, and since the epidemic prevention measure of Taiwan Tech, our class practice are changed to simulation. Okay, so back to the Zener diode characteristic. And first step, this one's the equipment and material you need to use, since we just using the simulation, so we don't care about this one. Okay, so the next part, experimental procedure. 2.1 simple application of the Zener diode. Okay, first one, connect according to figure 1.5 and adjust the voltage measurement record of the DC power supply Vs. And the voltage of VL is recording in table 1.4. Okay, so we take a look to the figure 1.5. Okay, so this the figure 1.5. And this one is the VS R1 Zener diode 1N4733, and this one's RL 2.2 k ohm. Okay, so we're using the simulation. Okay, I put the simulation software on the Moodle, you can check it. Okay, so this one I finished the circuit connect. This one the VS and R1, RL, and Zener diode. And Zener diode you can using the left button to select the component using. This one is the voltage source, current source, and the resistance. And this one is for the Zener diode, and this one is common ground. There is some probe and meter. This one is voltage meter, ammeter. Okay, I select the Zener diode to show you how to use. First one, this one is Zener diode, and this one is to the resistor. Double click, you can change the name, resistor value maybe to the 1 mega ohm. Okay, so double click again, you can change it to 1. Since we're just using 1N4733, so So we select the new one 1M4733 and press enter. And here, when your mouse hover on the component, see the dot and click and drop connect another point, you'll be connected directly. Instead of another one, so hover and press and drop to another point. This finish your circuit. Don't forget to add some ground on the circuit, and since the simulation needs the reference voltage on the 0 volt of the 0 volt, so the common ground is the 0 volt reference voltage. Okay, so I delete this one. Okay, so back to our assignment. So first assignment, connect according to the figure 1.5 and adjust the voltage measurement record of the DC power supply VS. So we need to adjust our VS like this one. Okay, so the table 1.4. Okay, I did this one. Okay, so first step, change the VS to a 2 volt. Double click and enter the 2 and press enter. Okay, so this one, I think this one is the wrong number. This one is the 2.2k ohm. Okay, so the first, the VL of the voltage across aisle is equal to 1.818 volt, and the IL means the current core IL equal to the 826.4 volt microampere, and IR1 is here is equal to 826.4 volt, 26.4 microampere. The IS, what is IS? What is IS? IS means the current from the power source. The power source is here, and the current from the power source is equal to IR1. This is VS and R1 in the series circuit. So the IS equal to IR1, IS equal to IR1, and IZ. Here's IZ. IZ is equal to 0. Okay, so 0. And next step, we change it to the 4 volt. 4 volt, VL equal to 3.633 volt, and the IL, you can fill in all the value by yourself. We just care about the VZ and RZ. So IZ equal to 0, also equal to 0 ampere. So what does 0 ampere mean on the Zener diode? It means that if the Zener diode doesn't work, the current on the Zener diode will be 0. If the Zener diode works, the current will not be 0. Okay, so the next one, 6 volt. So VL equal to 5.022. Okay, so see IZ. What is the IZ? How about the IZ? IZ equal to 2.136 milliamp. So from here, from now, the VS equal to 6 volt. The Zener diode getting start work. Okay, so next one, 8 volt. And 8 volt, see, VL equal to 5.073, and IZ equal to 11 milliampere. And so it works. The Zener diode works. So we change to a 10 volt. The VL equal to 5.097, and the IZ equal to the 19.97 milliampere. Okay, so we can see this one. The IZ at the 2 volt and 4 volt is equal to 0 since the Zener diode doesn't work. But when we increase the VS over 6 volt, the IZ starting the Zener diode getting work. So the IZ will be some value like 2.1 and 11.19 milliampere. So when the Zener diode work, we can see the VL 5.022, 5.073, 5.097. When the Zener diode getting work, the voltage across the Zener diode will be clamping by the breakdown voltage of the Zener diode. So double click, check by this one. The VZ means the breakdown voltage of the Zener diode, equal to 5.1 volt. So when the Zener diode getting work, the voltage across the Zener diode will be clamping to the 5.1 volt. We can change to another one to check the value. If we change to the 3.4, you can see Zener diode work right. IZ not bigger than not 0. So the Zener diode works, and the VL means the voltage across the IL equal to the voltage across the Zener diode, equal to 3.4 volt. 3.4 is the value we set in. So the voltage has been clamping at 3.4 volt. If we change to another one, 5 volt, see? Almost sent to the 3.4 volt, right? Since the Zener diode works, so the voltage clamping by the Zener diode. So this one is the Zener diode characteristic. Okay, so this one is the first part. We adjust the VS to check the Zener diode, the characteristic. Okay, so this one is the first part of the Zener diode, first part assignment for Zener diode, and another part is, okay, so we take a look according to figure 1.6, and the voltage output of the power supply is 12 volt, and the SVR is just to the max value of the 1 k ohm. What does it mean? Where is the different than the previous assignment? The previous assignment we fix the output resistance IL, and we adjust the VS from the 2 volt, 4 volt, 6 volt, and 8 volt to 10 volt, and then we can check the VL and the IZ. But now we using another way. First, this way is we fix the VS to the 12 volt, fix the value to 12 volt, and the SVR mean the variable resistance. So the IL will be changed. The max value is 1 k ohm. Okay, so the circuit figure 1.6 is almost the same as the 1.5, figure 1.5. VS, R1, and Zener diode, and RL. There's different, just like the VS. This one's variable, and this one is fixed, and this one is fixed, and this one is SVR, variable resistor. Okay, so we take a look to the table 1.5. Okay, I delete all the data. So first step, the SVR, we change the variable resistance to the 1 k ohm. So 1 k ohm and 12 volt, and this one is 220 ohm. Okay, so the VL first. Oh, okay. So we need this one. We're using a new one. Since in the previous test I changed the parameter of the Zener diode. So get a new one. And this one 1N4377. Finish. Okay, so VL first one, when the IL equal to 1 k ohm, the VL equal to 5.11, and the IZ is 26.21 milliampere. So what does it mean? When the when the output resistance equal to the 1 k ohm, the Zener diode works, and the IZ will not be a 0 ampere. So next step, change to 750. So the IL change to the 750 ohm, and the VL equal to the 5.107, and the IZ equal to the 24.52 milliampere. It also works when the output resistance equal to 750 volt, 50 ohm. And next one, change to the 500. The IZ will not another 0, so the Zener diode works. So the VL has been camping to the 5.1 volt, and the IZ equal to the 21.17 milliampere. Sorry, IZ 21.17 milliampere. And next one, change to the 250. So IZ equal to 11.19 milliampere, and so the Zener diode works, and the voltage clamping to the 5.1 volt. So VL almost equal to 5.1073, and IZ equal to 11.19 milliampere. and the last one to the 100 ohm. Okay, see, when we check the VL, before we check the VL, see the IL equal to 0 ampere. What does it mean? It means the Zener diode doesn't work, so the voltage across the Zener diode will not be camping by the Zener diode, will be depend on the R1 and RL and the VS. So the VL is equal to 3.775. Yep. So we can take a look data for the 1K 705 and the 1K ohm to the 250 ohm. The Zener diode works and the IZ will not be the 0, and the voltage across the VL will be camping by the Zener diode 5.1 volt. But when we change the resistor to the 100 ohm, the IZ be 0, and since the Zener diode doesn't work, and the VL is depending on R1 and RL and VS, so the voltage will not be camping by the Zener diode. Okay, so finish your table 1.4 and table 1.5. You need to finish these two tables, and using the simulation, you didn't to screenshot the circuit to me. You just finish it, fill in the value in the table, and hang in your assignment in time, and don't forget to write down your comment. Okay, thank you.
Here are our components that we need to use in this course. First, Zener diode 1N4733. Second, resistors like 220 ohm, 1 k ohm and 2.2 k ohm. Final, the variable resistor SVR 1 k ohm. Take the number 1N4733 Zener diode and connect as shown in Fig. 1.4. The input voltage VSEC is 12 VPP at 60 Hz. R connects to positive probe. B connects to negative probe. Transpose the time div of the oscilloscope to XY mode, and the y-axis of 1 kΩ becomes current, 1 mA per volt. Record the picture in Fig. 1.7. 2.2 Simple application of Zener diode connect according to Fig. 1.5. Adjust the voltage measurement record of the power supply versus the voltage of VL is recorded in Table 1.4. Use Ohm's law to calculate the load current IL. VR1 can be obtained by KVL. VSVL can be obtained, and as can be obtained by Ohm's law VR1, R1. Connect according to Fig. 1.6. The voltage output of the power supply is 12 volts, and the SVR is adjusted to the maximum value of 1 kΩ. Measure the voltage of VL and record it in Table 1.5. Use Ohm's law to calculate the load current IL. VR1 can be obtained by KVL. VSVL can be obtained, and as can be obtained by Ohm's law VR1, R1.